Hello, on behalf of my group, I would like to welcome you to the Brain and Cognitive Function in Adulthood. My name is Stacy Mortimer, and I'm going to take us through a micro-learning that provides an overview of the brain and cognitive function in adulthood. So we begin by taking a look at our two objectives. The first objective is to define learning and cognition. And the second objective is to identify one technique for improving adult learning based on the biology of the brain. We begin with a definition of learning. Many psychologists define learning as a change in behavior that results from experience. But what does this actually look like on a biological level? To answer this question, we have to take a look at neurons. So the brain is made up of about 10 billion neurons with electrical currents passing between them. These neural impulses travel between 2 and 200 miles per hour. Scientists believe that learning is the growth of synaptic connections between two or more neurons in the brain in a process called long-term potentiation. Although our ability to grow new brain cells is limited, we can build virtually limitless connections between the different neurons in the brain. So each neuron in our brain has approximately 10,000 contacts with other neurons. We end up with about 400 trillion synaptic connections. There are more synaptic connections than there are stars in our galaxy, and I think this is pretty awesome. What you're looking at now is a video of a neuron that is attempting to grow a synaptic connection with another neuron that doesn't actually exist. But you can see those axons reaching out, trying to find a connection with another neuron. The more that we use neurons, the deeper the connection that grows between the neurons. So the first time you learn a piece of information, for example, this idea of long-term potentiation, it's a little bit like blazing a trail through the wilderness where it's a little bit difficult to walk down. But the more that you use it, the more it becomes like a highway. And over time, these highways connect with other highways in a really complex network. So neurons that fire together tend to wire together, and they wire together into neural networks. And we have all kinds of neural networks within our brain. A common one might be for vision, which is a string of neurons that are all wired together that help us to see the world around us. The more you use your brain, the more neural connections you make. It's a little bit like a muscle. So how does this compare with cognition? Most psychologists loosely define thinking or cognition as everything that the conscious mind does, including processing, understanding, remembering, and communicating. And so basically cognition is a little bit like what you do with the information that you learn. When we learn information, our brain is actively making connections to earlier information and organizing it in different ways. And our brain tends to organize things according to 3 different ways. Those are our hierarchies, semantic networks, and schemas. And so this is a good example of a hierarchy, a system in which concepts are arranged from more general to more specific classes. Semantic networks are a little bit different. Semantic networks are more irregular and distorted systems than hierarchies with multiple links from one concept to others. It's a little bit like a spider web. And so this might be a semantic network within my brain. And so if you think about the concept of brain, within my own brain, it connects in with this idea of hemispheres, right? There's more than one hemisphere in our brain. It also connects in with a cartoon called Pinky and the Brain. It connects in with this idea of biology. And I first took biology at Forest Hills Northern from Mr. Bowser, and connected in with Forest Hills Northern is an interesting tidbit of information. Taylor Lautner attended Forest Hills Northern way after I did, I should say, but he's a kind of a famous werewolf and a kind of famous vampire movie. And so this might be an example of a semantic network within my own brain. And finally, schemas. Schemas are pre-existing mental frameworks that start as basic operations and they get more and more complex as we gain additional information. So, for example, if I say the word superhero, you probably have some thoughts that pop into mind, right? When I say superhero for myself, perhaps Wonder Woman jumps into my brain. And the longer I live, the more elaborate this schema for a superhero becomes. And we have schemas for all kinds of things, and they influence us in lots and lots of different ways. And so you have schemas for what a school should look like, for example, or perhaps for what a wedding should be like. And again, these things can have some pretty profound influence on the way that we think about things. So here is our learning tip. How can we learn this to improve adult learning? And one piece of advice I would give you is graphic organizers. And so many of you are familiar with different kinds of graphic organizers that are out there. And graphic organizers can be very powerful for our brain. And so, for example, if you think of our brain a little bit like a closet, when you provide graphic organizers for learners, what you are essentially doing is taking their closet and you are organizing it in a way so that it is easy to access information. And so our learning tip for adult learners is graphic organizers. All right, so our objectives for today were to define learning and cognition and to identify one technique for improving adult learning based on the biology of the brain. I hope I was able to do that with you today, and I wish you luck as you move through our different learning activities.